I'm back, baby. So now we're going to take a look at what we call the product rule. This is how we take the derivative when we multiply two functions together. So let's let h of x be defined as the product of both f times g of x. These are going to be two different functions. F of x and g of x are different functions. And we're multiplying them together. And we want to know what the derivative would be. Well, we're not going to go into how we get this rule. We're just going to talk about what the rule is. And this is pretty easy to rule. What we're going to do is we're going to take the first function, f of x, multiply that by the derivative of our second function. So it's f times g prime. Plus the second function, multiply that by the derivative of the first function. And that's it. Some books and some teachers, even tutors, will switch those around, but just leave it like that. It makes it really easy. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. So all we have to determine is which function's our first one, which one's our second one. And it's pretty easy to do. Let's look at number 1 here. We have f of x is 2x times cosine of x. I can imagine this 2x as being my first function. I'll call that f. And the cosine of x being my second function, which we'll call g. And so there you go, f of x and g of x. We have two distinct functions right here. F, which is 2x, g of x, which is cosine of x. When we want to take the derivative, we just have to follow our rule. The first function, we're just going to write it down, f of x, which we're saying is 2x, multiply that by the derivative of g, of the second function, which is cosine of x. That's going to give us this negative sine of x. Plus, now we're just going to write out what the second function is, which for us is just cosine of x, times, and now we want the derivative of our first, which is our 2x. Well, what's the derivative of 2x? Oh, that's just 2. This is your answer. Don't simplify. I don't think, Mr. Wernell, my parents need me to simplify. If you do, negative 2x sine x plus 2 cosine of x. And there's our answer. Easy peasy. So let's take a look at g. What up, g? Number 2. Well, if I'm thinking of my first function, well, there's my first function. The sine of x, that's my second function. I don't like the way this is written. I don't like radicals. So I'm going to write this as x to the 1/2 times sine of x. Still the same thing. There is my first, there is my second function. When we apply our rule, g prime of x, we're going to take the first, x to the 1/2 times the derivative of sine, which is cosine of x, plus take the second function, which is our sine of x, multiply that by the derivative of the first. Be very careful. This is 1/2 x to the negative 1/2. So g prime of x, we get x to the 1/2 cosine of x plus, remember, we talked about this in another video, no negative exponents. We don't like that, so we're going to rewrite this, right? So no negative exponents. There we go. When I rewrite this, we're going to get 1/2, and the x to the 1/2 also goes on bottom. Whoops, I forgot to multiply by my sine x. So let me write that and make it look like what it should look like a little bit better for you. So g prime of x would equal x to the 1/2 cosine of x plus sine of x times, and now I'll do my 1/2, 1/2 x to the 1/2. And there is our derivative. Easy peasy. All right, pause and try number 3 real quick. Okay, now there is another way we can do this. We actually solve this one with product power rule. We can just distribute, but let's just practice our product rule here. So to get f prime, we have our first function and we have our second function. my rule, write out the first function, that's just going to become x cubed, times the derivative of our second, which is going to be 4x cubed minus 6, plus the second function, x to the fourth minus 6x, times the derivative of the first, 3x squared. Ran out of room. Don't simplify, just leave it alone. We don't care what it looks like. It's nasty, but you know what? It's ours. All right, so again, pause, take pause if you need to. Try number 4. Now, number 4, you might notice, is kind of scary because we're multiplying 3 functions together. Now, there's a few ways we can do this. One, I can take the derivative of the first two, then multiply that by the derivative of the second one. That becomes pretty nasty. But, man, this isn't so bad. I'm just going to simplify this. I'm going to distribute. Just the next second two. So g of x then will just become this, x squared minus 3. This one's not that hard. We get x squared plus x minus 2. And now I'm down to my first and my second function. Now the derivative is going to be a piece of cake. Take the first function, which is this x squared minus 3, times the derivative of our second, 2x plus 1, that shouldn't be too hard, plus the second, x squared plus x minus 2, and I'm going to multiply by the derivative of x squared minus 3, which is easy, just 2x. Dos Equis. Stay nerdy, my friends. And there we go. Piece of cake. Do not simplify. Whoops, sorry. Tilt it up, other way. Do not simplify these. All right. We just want to get an answer. Don't simplify them. All right, so for number 5, let's see here. Again, I'm multiplying. I'm using my product rule. There's my first, and there's my second. This one's pretty nasty, so I'm going to rewrite it, cosine of x minus x to the 1/4. That's going to become an issue for us later on, but right now we're not going to worry too much. Now, since I used y, I'm going to be fancy. I'm going to say dy dx. We take the first function, which is a sine of x plus 2, times the derivative of the second, which is negative sine of x minus, remember, this now becomes 1/4 x, subtract 1 to the negative 3/4. We'll talk about that. Plus the second, which is this cosine of x, plus x to the 1/4, times the derivative of the first, cosine of x plus 2. That is, look how ugly that is. It's not supposed to be, we just want to get an answer. But we're not done, because remember, we don't like this negative exponent. So now I'm going to rewrite the whole thing just to get rid of that. Sine x plus 2, negative sine of x, plus this becomes 1/4 x to the 3/4, plus cosine of x plus x to the 1/4 times cosine of x plus 2. I mean, that is awful looking. Homecoming's coming up. If my data looks like that, I'd be like, go back home, go fix it up. All right. So there's our derivative. Very easy to do. And honestly, they don't get much uglier than number 5 right there. Now, there is a shortcut we can do with this. At another video, I will show you a shortcut for doing these little power rules right here, okay? All right. But in the meantime, let's talk about how the AP will do it. We've talked about these earlier. We call these analytic derivatives. We're given the graphs of f and g below, and we want to answer the following. They tell us h of x is the product of f of x times g of x, and they want us to find h prime of a. Notice they're looking for the slope, therefore we need the derivative. So I have to take the derivative of h. Now please be careful. This is what you're going to want to do. Everybody wants to do this. You're going to want to say, h prime of x is just f prime of x times g prime of x. No. We're multiplying. This is our product rule. Please be careful. And our product rule says to take the first function, multiply it by the derivative of the second, plus the second function times the derivative of the first. Now, this is big on the AP exam. They're not going to give you something like number 5 on the AP exam. If they want you to do product rule, they'll give you something like this, where you just literally just write out the product rule. And they're going to give you plus 2 points for that. So am I. Just take that derivative. Get 2 points. Now we're going to plug in the 8. H prime of 8. Well, if I just plug these in, this just becomes fate. I get it. Fate, f of 8, times g prime of 8 plus g of 8, shut the gate, times f prime of 8. Everywhere there's an x, I just plugged in an 8. So let's see what this means for us. Well, this is talking about the value of f at 8. So to get h prime of 8, I go to 8 and I go up to f. Well, if this is g, this must be f of x up top. At 8, I want the value, which is 6, times this one, g prime, I want the slope of g at 8. So here's g. At 8 looks like the slope is going down 1 over 1. So the slope looks like negative 1. Plus g of 8, again, that's the value at 8 for g. There's g. Now I want the value at 8, which is 3. Times, same thing, I now want the slope of f at 8. So at 8, what's our slope going to be? Oh, I got to find the slope here. Here's a point. Looks like there's a point. Not perfect, but it looks like I'm going to go up 2 over 1. So the slope there looks like it's going to be 2. And I can simplify this. I get negative 6 plus 6, which is 0, which is interesting. Remember, when the slope is 0, we call that a critical number. This is a critical number for h of x. H of 8 is a critical number. Down there, we know that the slope is 0. Fun stuff. All right, you're going to see questions like this on your homework tonight. So I just want to take a look here. There's really nothing really special about these. These, we'll just kind of like review. I can bring my x squared to the top, right? This just becomes f of x equals 5/3 x to the negative 2. Taking the derivative now, we get negative 10/3 over x cubed. How did I get that? Remember, this becomes negative 10 over 3x to the negative 3. We should just be able to, I just want you to go straight to your answer if you can. That's fine. Over here, because it's a single, ladies, we're going to split the fraction. And we get 3x squared over x plus 4 over x. And if I simplify that, we get 3x plus 4x to the negative 1. When we take that derivative, we're going to get 3 minus 4 x to the negative 2. Or 3 minus 4 over x squared. And there's your derivative. I hope you enjoyed the video. Go to my next video, and I'm going to show you some tricks with the rationals, with the radicals. Okay? I'll see you then. Bye-bye.